So let's see how we can bring these two concepts we've been discussing, end behavior and multiplicity, together to get the complete sketch of a polynomial. All right, so we're going to follow both paths here. All right, first, let's find the roots, right, and think about their multiplicities. Well, the x minus 1 factor gives me x equals 1, and the minus 2x plus 8 factor gives me minus 2x is negative 8, x equals 4. Okay, good. Now, what are the multiplicities of these things? Well, the multiplicity of x equals 1 is 2, and the multiplicity of 4 is 3. So I know my conclusion here, it's going to touch the graph at x equals 1, and it's going to cross the graph at x equals 4. All right, so let's put those on here. Right, I'm going to put 1. I'm going to go 1, 2, 3, 4. And the way I do this is just my own personal approach. I'm going to put an x here at the ones that just touch. That's my note to myself. Don't cross, right? Don't cross the axis at that point. All right, so now let's think about end behavior. Remember, end behavior is based strictly on the leading coefficient, and the leading coefficient of the polynomial comes from the leading coefficients of the factors combined with the exponents. All right, so the leading coefficient of this thing will be x squared times negative 2x cubed. So let's see, negative 2 to the third, that's negative 8. This will be x to the 5th. All right, so if I put a really big positive number in there, I'm going to get a really big negative number out. So the graph is going to start, it's not going to start, it's going to end over there going down to the right. Then what happens on the other side? If I put a really big negative number in there, raise it to the 5th power, it's negative, multiply that by negative 8, and it becomes positive. So it's going to be going up to the left, and that's what I need to know. Right, now I can sketch my graph. Right, and so the graph is going to come down, touch this intercept, come back up, go down through this one, and take off down to the right. And that's it. There's the sketch of my graph. All right, so let's try another one here. A little bigger, right? A little bigger. The pitfall here that I see happen with students sometimes is they forget that minus 2x squared is a factor. It counts. It's going to contribute a root, an intercept, and it's going to contribute to the multiplicity, right, to the end behavior. So let's get our three roots here. Negative 2x squared equals 0 when x equals 0. And the multiplicity there is 2, which means the graph will touch the axis. 3 minus x equals 0 gives me x equals 3. And the multiplicity here is 3, so it will cross. And finally, this one, x plus 8, gives me x equals negative 8. And this is the same as the previous one. Multiplicity is 3, so it will cross the axis. Excellent. Now, let's sketch that, right? I'm going to put 0 is here, and that's a touch, so I'm going to put a little x there to let me know not to cross. Then, when you're doing this, because I keep having this issue as I'm looking at these, be sure that you're graphing the roots and not the multiplicities. So I'm going to do x equals 3, and that's going to be a cross, and we'll do x equals -8, and that will also be a cross. Right, so now let's get the x behavior, the end behavior. I'm going to be looking here, here, and here. So we've got -2x squared times -x to the third times x to the third. So let's see, -x to the third is still negative. So that negative times the -2, that's going to become +2, and it's going to be x to the 8th. All right, so again, no matter what number you put in there for x, positive or negative, when you raise it to the 8th power, it's positive. So it doesn't matter what number you put in there, a big positive number or a big negative number, you're going to get a big positive number back out. So it's going to be going up over here and up over here. And this is the point where a little bit you cross your fingers, right? And I hope that the touching and crossing work out the way you expected them to. So it's going to cross here, come back up, touch here, cross here, and there you go. And take off back up. And that's it, right? There's the graph of this polynomial. All right, so in the next lecture, I've got some more examples where we can use these tools. We're actually kind of take a step back as well. Instead of giving you the factor form, we're just going to start with a regulation polynomial, and we're gonna have some more steps. We're going to first have to factor it to get the roots and the multiplicities, and we'll use, for example, some of the factoring techniques that we've talked about in previous sections to do that.